Alrighty, so today we're going to be doing the last skill. Doesn't that make you a little bit happy? Unit 11, Skill 10. How do we calculate the difference in means, which is pretty much a joke, it's difference. That means subtract. And then determine what is likely to or unlikely to occur. And that also is fairly straightforward once we get past it. So there's some understanding parts to doing it, but the actual math work that we're going to do is very basic, but it is based off of the understanding. So again, you want to make sure that you are paying attention to what we're going through here and how things are playing out, what's happening. Alright, so take a second to go through, pause the video, and read what's happening here, and then we'll kind of go through it very briefly. So we're doing an experiment where we are keeping a lot of things the same, right? So we're keeping similar conditions, soil, water, sunlight. Those are part of the controls of the group, right? We're going to keep those the same, but 5 of the tomatoes get additional nutrient supplement, whereas the other 5 are not. And we want to know, using the weights, can we determine if the nutrients yield larger tomatoes? So here it's 10 tomatoes, and their weights shown, from largest to smallest based off of weight. So there's the largest, there would be the smallest. Right now we're not going to be worrying about which one got which. Okay, we're just going to jump right into a simulation. So the idea of what's going on, just to have some understanding. So imagine, all right, someone's assisting you, and use a random number generator or some other impartial device that's not going to be biased to select tomatoes 1, 4, 5, 7, and 10 to be group A, and then 2, 3, 6, 8, 9 are group B. We need to calculate the mean for group A and the mean for group B. Well, the mean for group A is pretty simple. You type in the calculator. You are going to add all of these up, divide by 1, 2, 3, 4, 5, and you get the answer. So works out to be that x bar sub A, that means it's the average of A, right? X bar sub A is going to be 6.76. And when you do the same thing, add them all up and divide, you get B, which is 6.48. So it says, part B, calculate the difference between the mean of group A and the mean of group B. All right, and then explain the meaning of this result. So we're going to subtract 6.76 minus 6.48. We end up with 0.28 ounces. So explain the meaning in this. Explain in the math problem. You need to understand this. You memorize it. It means write out in words, not just show your work. Justify, show your work. So we're going to say the average weight of group A is 0.28, 28 hundredths of an ounce more than the average weight of group B. So pause it and write that. So there it is. The average weight of group A is 28 hundredths or 0.28 ounces more than the average weight of group B. Fairly straightforward. Take a second, pause it, copy that down. So we did the average minus the average. That's it. Next page. So imagine that random assignment was done 250 times. They did 250 subtractions, so diff values from that, from those 250 random assignments. We have the dot plot that we see right here. That dot plot, if you look at it closely, looks somewhat symmetric. It's somewhat approximately normal. All right, it's not perfect, but it does follow that bell-shaped curve, roughly. So we're going to answer some questions based off of that. I'm going to skip over part A and just jump right into the part B question, if it'll ever work. So given the distribution shown in this lesson, if you had obtained a diff value of 0.28 ounces in your experiment, would you consider this a statistically significant value? So what does it mean to be statistically significant? All right, well that word right there, which I can't seem to underline, that word right there means it is an unlikely event. It's unlikely to occur due to random variations is what that means, okay? And that's something that you do need to know. So we want to know, is 0.28 considered an unlikely event? Well, unlikely, we know, means rare, not occurring very often. So we're going to go and plot that line on there, 0.28, where we think it might be, roughly. It's not going to be perfect. Yeah, horrible line, but you get the idea. So there's 0.28, okay? And we want to know, is that likely? So to figure out if that is a likely or an unlikely event, we're going to add up all those dots. And it's as simple as doing that. So when I add up all those dots, because I'm really quick, I got 80. All right? Roughly 80 out of, 250. Now 80 out of 250, you go to your calculator, type it in, is 0.32. So we get 0.32, which is a 32% chance of that happening. Is 32% chance likely or unlikely? Well, we say something is unlikely if it's outside of 2 standard deviations, which means less than 5%. So is 0.32 going to be less than our 0.05? No, it's not. 32 is not less than 5. There's a 30% chance, which means there is not a statistically significant difference. I'm going to write that down and then talk about the answer. So here's the explanation. We're going to say there is not, all right, there is not a statistically significant difference as a diff value of 0.28 or more occurs 80 out of 250 times, which is a likely amount. That's why it's not statistically significant. So why did I say or more? Some people have been asking that question. Where did the or more come from? How did I not know to do or less? Well, I looked at this value and I said, you know what, this is to the right of the middle. And since it's to the right, we're going to do or more. If it was a number that was left of the middle, let's say it was negative 1.6, I'd draw it over here, and I would be doing or less because it is left of the middle. So the or more or less part that we have here is going to be that. All right? Let's move on and try another one. So given the distribution shown in the lesson, if we had obtained a diff value, a difference of 2.44, okay, for the tomatoes experiment, would we have, say that the diff value was extreme enough to support the conclusion that the nutrient treatment yielded heavier tomatoes? So what they're saying is it statistically significant? Is it a statistically significant enough where we can say, yeah, it's heavier tomatoes? So let's zoom out here. 2.44. So 2.44 occurs right about here. I'm going to try and draw my line perfectly, and it's not going to. Yep, there's one value right here. So there's only one value that occurs higher than 2.44. So for that one value out of 250, well, we know that 1 out of 250 is very, very small. It is less than 5%, which means it is, in fact, statistically significant. And that's significant enough that we can say, hey, they must have heavier tomatoes on average. So I'm going to write that out, and then we'll talk about it again. You can say there is a statistically significant difference as a diff value of 2.44 or more occurs 1 out of 250 times, which is unlikely. So taking a look up here, all right, we found that there was only one dot, and you really can't see it. Maybe I can erase right here. This one dot right there after 2.4, so that must be the 2.44, a little bit more than that. And since it only occurs one time out of 250, which is 0.4 or 0.004, so 0.4%, that's definitely less than 5%, which means it is unlikely. All right, if it's more than 5%, that means it must be within that 95% confidence interval, which is a likely event. This one's outside of it. All right, let me go through and underline for you the parts that change. So the parts that can change would be there is or is not a significant difference as a diff value of. That number is going to change. We're not always doing more. All right, it's not always going to be the same fraction, and you're not always going to use the word unlikely. You might use the word likely. Let's do another problem. Call it quits. So in this question, we have 20 people that are in pain. They're going to be given a medication and not a medication. It's randomly done. It's an experiment. That way they can figure out, because treatment is imposed, if it's actually working. Right? That's how you know something's an experiment. All right. So they go through and they give these people, group A gets the treatment and group B gets the placebo, which means they don't know if they're getting the treatment or not. So group A has a pain reduction, negative 4.2. And group B's is negative 3.4. What we want to know is there's a difference in there, and that difference is negative 0.8. So that's the average difference when we have to subtract. When it says calculate the mean difference, group A minus B, well, negative 4.2 minus negative 3.4 is negative 0.8. So what we can say is, on average, group A has 0.8 or 0.8 more pain reduction than group B. All right? That's all that's really talking about. You'll notice that it gave us the S of X. People are asking about that. That's just the standard deviation. You will never use that in a problem where we're doing the difference of means. In a question where they're just giving you a mean and standard deviation, you might use this. But when you see two of them, you can just essentially think in your brain, I don't need that, cross it out. It's extra information that's designed to throw me off. All I care about is, can you subtract those two numbers? That's not that difficult. So, okay, so now we jump into Part B. Based on your sample and the simulation, would you consider the new treatment being effective on average in relieving pain? Which is really saying, is it a statistically significant difference? And again, from the previous page, statistically significant means Is it unlikely? Is it rare? Okay, is it in or lower than 5% is what we're really looking for. So we take and we put our negative 0.8 line on here. Okay, and I'm just going to count, since it's clearly to the left of the middle. I would say that the middle is probably somewhere right in here, right? Clearly to the left of the middle. We're going to be doing the less than side, and we're going to count up everything that's less than the negative 0.8. Not really including the negative 0.8, but counting up everything that's less than it. So count those dots up, and I have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 or so dots out of 20. So if I have those 11 dots, I'm not sorry, out of 20, out of 100. So 11 out of 100 is what we ended up with. I apologize. So 11, come on, out of 100 is 11%. That is definitely more than 5, which means this is likely. This is inside the bounds that would occur due to random variability, so it is a likely event. Write the conclusion, and then we'll talk about it. Okay, so here we have it. There is not a statistically significant difference as a diff value of negative 0.8 or less occurs 11 out of 100 times, which is likely to happen. And that's it. Again, I underlined the parts that change, and that's that. Some people have a hard time figuring out what goes with what. So I'm going to summarize real quick, and then we'll go through it. So less than 5% means, okay, so if we have a number that's less than 5%, all right, it's going to mean that it is statistically significant, which means it is unlikely. More than 5%, all right, means we're going to have not statistically significant, all right, which is a likely event. And you do want to put those three together. So when we're filling in the blanks, all right, first you figure out the fraction that we have up here, which was 11 out of 100. That is more than. That means we're going to write not significant, and we're going to write likely. The less or more that we're going to put in there all depends on whether we are to the left or to the right of the middle. Now, if it was positive 0.8 over here, okay, or maybe 0.6, come on, today, you would then add up all of these guys right here, because that's to the right, or to the right of the middle, so we add or more, and we would say more than or more occurs in this question. That's it. If you've copied the summary value, or the summary statement in previous days, we're going to amend that a little bit to make it a little bit shorter. So just take a look up at the front board or listen for your teacher to tell you. Okay, but that summary statement is going to change for my guys because I had them copy it already. So for 1110, that is going to change.